In this video, let's talk about view watchers. For the front-end development, it is common to perform actions in response to changes in reactive data. Let me show you some use cases. If a user inputs data into a form, we want to validate this input against certain criteria and provide immediate feedback. For example, there is a form with an email input field, and we want to validate the email format in real time as the user types, providing immediate feedback on the validity of the entered email. We may want to react to data changes that require asynchronous operations, such as fetching data from an API endpoint when a user's input changes. For example, we have a text input for a user to type a username. As the user finishes typing, we want to perform an asynchronous API call to the backend to check if the username is available. We may need to perform an action only when a specific piece of data reaches a certain state or changes in a particular way. In other words, execute code under certain conditions. For example, we have a notification component that should only appear when there are unread notifications. Additionally, if the number of unread notifications crosses a certain threshold, we want to perform a different action, like sending out a reminder or highlighting the notification icon. To handle those use cases, Vue.js provides a way to react to data changes through the watch function. Vue can only watch 4 types of data. It can be a ref, including computed refs, a reactive object, a getter function, which is a function that returns a value, or an array of the above types of data. This list is from Vue's official documentation. It's pretty vague and abstract. I summarized 4 common scenarios when using a Vue watcher. Understanding my examples will make you become a pro in Vue watchers. So let's go to VS Code. First, let me create a Git branch for this Vue concept, so it'll be easier for you to review the code later. Git branch watchers. Git switch watchers. So now we're on the watchers branch. Let's look at scenario 1. Here is the starter code for scenario 1. Watch a primitive type value wrapped by the ref method. In this example, we defined a number. Then we wrapped the integer number 1 in the ref method and assigned the returned ref info object to the number. The integer is a primitive type value. And here we're using number in the mustache notation. When we render it, number is 1. There's also a button. When I click this button, we increment this number by 1. Very simple. So if I click, it goes to 2, 3, 4, and 5. Next, let's define a watcher to watch this number. Please note, this number is really a primitive type value wrapped by a ref method. Okay, here is the syntax. Watch. Okay, make sure you import watch from Vue. Watch method takes 2 arguments. The first argument is the thing on the watch, which is number. It's a reactive data. The second argument is a function. And there are 2 arguments for this function. New value and old value. That is the old value and the new value of number. So here, let me console log a message. Watch a ref primitive value number changes. And let's print the new value and the old value of the number variable. Okay, let me refresh and press F12. And let's take a look at console. All right, now I'm going to increment number by 1 when the number changes, since this watcher is watching the content of number, if the content of the number changes, this function gets called. So really, the first argument is the thing under watch. The second argument is a callback function that gets executed once the number changes. So we're going to print a message, print the value before change, and then print the current most up-to-date value. All right, so here, let me increment number by 1. Now, as you can see, this message is printed. New value is 2, old value is 1. Now keep doing this. 3, 2, 4, 3, 5, 4. Can we stop a watcher? For sure. This watch function returns a value. So let's save that value in a variable. Let's call this stop watch. Or you can call it onWatch. It turns out that this is a method. After console.log, I'm going to add if new value is greater than 5, then stopwatch. And the stopwatch here refers to the stopwatch returned by the watch function. All right. Increment by 1, increment, 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 no problem. So now the value is 5. When I click again, the new value will be 6. So it is still printed, right? The new value is 6, old value is 5. But new value is 6, this is greater than 5. We're going to stop the watcher. Now if I click again, nothing happened because the watcher is stopped. All right. Next, let me talk about eager watchers. By default, a watcher is lazy. It means this callback function won't be called until the watched source has changed. But in some cases, we may want this callback function to be run eagerly. For example, maybe we want to fetch some initial data and then refetch the data whenever relevant state changes. Can we force a watcher's callback function be executed immediately? Sure. We can pass an option as the third argument to this watch method. So this is the first argument, and this callback is the second argument. And here, let me pass a third argument, and this is the JavaScript object. Immediate true. By default, it is false. So let me refresh. Pay attention to the console. Okay, as you can see, I haven't got a chance to click increment number by 1, and this watcher's callback function is invoked eagerly. Watch a ref primitive value, number changes, new value is 1, and what about the old value? Okay, that is undefined. Because there's no old value, I haven't clicked increment number by 1. If I click this button, now we have 2, 1, 3, 2, 4, 3, and so on and so forth. So this is called eager watcher. So if you want your watcher's callback to execute immediately when this page gets loaded, make sure you have the third argument, immediate true. By default, it is false. Okay, let's move on to scenario 2. Now let's look at scenario 2. Watch a property in an object wrapped by this ref method. In other words, watch a property in a ref object. In this simple example, I defined a JavaScript object, wizard1, with ID, name, house, age, and also it nests another object called wand. It has two properties, core and wood. And in this div, we're showing wizard1.name and also the wand object in wizard1. As you can see here, the JSON object is printed, core and wood. Next, I'm going to define 3 buttons to change the properties in wizard1. The first button is called change name to uppercase. That's pretty simple. Add click wizard1.name is equal to wizard1.name dot to uppercase. All right. So let's try to test. Now, as you can see, this is in uppercase. The next button is called change wand. So let's give Harry a new wand. Add click. I'm going to call a method change wizard1 wand. As you can see, I've already defined this method down here. It's very simple. This is a new wand with a new core and a new wood, which is assigned to wizard1.value.wand. Recall that since here we're in the script, we have to use wizard1.value. But you do not have to use .value after wand because this is automatically unwrapped. Okay, so let's test. Click change wand. Now Harry has a new wand. Let's move on to the third button. And this is change wand core. Add click wizard1 dot wand dot core is equal to, for example, unicorn hair. All right, so let's test. All right, so the core of the wand is changed to unicorn hair. All right, so far so good. My ultimate goal is to define watchers. So next, let me define two watchers. The first watcher watches the name of the wizard. The second watcher watches the wand of this wizard. So let me scroll down here. Watch. Make sure you import it from view. Recall that watch receives two arguments. The first one is the thing that's being watched, right? The source. The second one is a callback. Can we do this? Wizard1 dot value, of course, since we're in the script, dot name. And then here we have this callback. Remember here, optionally, you can have the new value and old value. You don't have to use them, right? But here I show you the complete version. Does it work? So here, let's press F12. And let's look at the warning here. Invalid watch source. So that means the first argument we pass to watch is not correct. A watch source can only be a getter effect function, a ref, a reactive object, or an array of these types. All right, that's exactly what I showed you on the slides, right? That means you cannot really directly watch a property of a ref object. Now instead, we should change this one to a function that returns wizard1.value.name. So we cut this. Instead, the first argument should be a function that returns this one. Let me do a console log. Watch a property in a ref object. Wizard1 name changes. And here I'm going to put the new value and old value. All right. Let's test this. So when I click change name to uppercase, this watcher's callback is supposed to be called. So watch this. If I click, all right, this callback function gets called. Watch a property in a ref object. Wizard1 name changes. This is the new value, Harry Potter, all in caps. And then the old value is Harry Potter. Great. That's how you watch a property in an object wrapped by the ref method. All right, then let's define the second watcher. So here, watch. And this time, we're going to watch the wand. Since wand is also a property of wizard1, right? So we cannot watch it directly. Instead, we need to use a function that returns the thing that to be watched. Wizard1 dot wand. Okay. And then the callback. New value, old value. And here, let me copy this console log and change it to wizard1 wand changes. Okay, as you can see, these two watchers are very similar. They're just watching different properties of an object. The first property happens to be a primitive value. The second property is itself an object. All right, so let's refresh. No error. Let me click change wand. All right, now recall that if I click change wand, let me show you the method. We're going to replace the old wand with an entire new wand. All right, do you think the watcher will get called? Maybe. Let's try. So let's click. All right, great. So this is the new value, the new wand, and this is the old wand. Very good. Okay, what about change wand core? So you see, I'm not changing this entire wand. I'm changing a property of the thing that I'm watching. I'm watching wizard1 wand, but I'm not changing the entire wand, but one of its properties. Are you with me? Let's see if it works. So I click change wand core. Take a look at the console. Do you think this watcher will be triggered? Let's see. Click change wand core. All right. The core is changed, but this watcher is not triggered. In other words, this callback function does not get called. You're like, what? Technically speaking, the wand is changed, right? Because if a property of the wand gets changed, okay, then we can say the wand is changed. Well, it turns out that it doesn't work that way. By default, watch is shallow. In this case, the callback of this watcher only gets called when the entire old wand gets replaced by a new wand, like this. If a property of this wand gets changed, the watcher would not detect that by default. Behind the scenes, this watcher is actually watching the address or the reference to this wand object in the wizard1. And when this method gets called, a new wand replaces the old wand. Thus, the address or the reference, or if you know C++, the pointer gets changed. That's what this watcher cares. But if only the property of the original wand gets changed, that will not trigger this watch because the address or reference or pointer of this wand is still the same. And I can prove this to you. How? We can actually force this watch to get triggered by passing a third argument to this watch function. You see, this is the first argument, this is the second one, and we can pass a third one. This time it is deep watch. I think the name explains everything, right? That means we're asking the watcher to not only watch the address or the reference or the pointer of this wand, but also watch all its properties. If any property in the wand gets changed, fire this callback function. Okay, so let's refresh. Now this time, if I click change wand core, all right, great, this callback gets called. But wait a sec, why the new value and old value are the same? Do you remember what I just said? Because the address or reference or pointer of wand does not change. That's why the new value and old value are the same, both pointing to the same object. Okay, that's for scenario 2. Let's move on to scenario 3. This is scenario 3. Watch an object wrapped by the ref method. In other words, watch a ref object. Here we defined a JavaScript object, wizard2, with ID, name, house, age, wand. And wand has two properties, core and wood. This is similar to scenario 2. And here we're printing the name and also the wand of this wizard. And there are 3 buttons: change name to uppercase, change wand core, and change the entire wizard. So pretty similar to scenario 2. And I want to show you change wizard. So basically, we have a brand new wizard, a brand new JavaScript object that replaces the old wizard object. And behind the scenes in the RAM, the address or reference or pointer to the wizard object changes, right? So there are 2 wizards. One is Ron Wesley, and the new one is Hermione Granger. And they occupy different space in the RAM. They have different references or pointers. All right. So let's test. Change name to uppercase. No problem. Change wand core. No problem. And change wizard. Okay, everything got changed. Name and wand. Okay. So in this case, I only want to define one watcher to watch this wizard 2. So let's scroll down here. Watch wizard 2. Since wizard 2 is a ref object, I do not have to use a function to return it. I can simply just watch this object, no problem. And here we have the new value, old value, console.log, watch a ref object, wizard 2 changes, new value and old value. All right. Okay, so no error. Let's test. So can you tell me, if I click change name to uppercase, will this callback get executed? Let's give it a try. Change name to uppercase. All right, the name is changed, but the watcher is not triggered. Okay. What about change wand core? If I click change wand core, it gets changed, but the watcher is not triggered. Then what about change this entire wizard? Now here is the logic to change the entire wizard. Recall that in scenario 2, I said when a watcher is watching an object, it can be a ref object, or it can be an object as a property of another object. Anyway, if it's an object, it only watches the address or the reference or the pointer change. So I'm pretty sure if I click change wizard, this watcher will act. Okay, so let's see. Change wizard. All right, great. It is working, right? And here it shows me this is the new value, the new wizard, and this is the old wizard. Very good. So let's do a small summary here. By default, if we ask the watcher to watch an object, the watcher is watching the address or reference or pointer change of the object wrapped in the ref method. If you need to watch its internal properties, we must manually turn on the deep watch. So if you really want this watcher to be triggered by name change and also wand core change, so here we're going to pass a third argument. It is deep. By default, it's false, but then we're going to make it true. Okay, so let me refresh. Let's test. Change name to uppercase. Boom, works. But as I said before, the new value and old value, they are the same because the reference to the object does not change. It is still the same object. Okay, that's why they are exactly the same. All right. Then let me click change wand core. All right, it also gets triggered, but same thing. New value and old value, they're the same. Okay. Now only when I change wizard, I have a different new value and old value because there are two different objects. That's something you need to pay attention to when you watch a ref object. Okay, next, let's look at the last scenario. All right, this is the last scenario, scenario 4. Watch an array of ref primitive value, a property of a ref object, and a ref object. And here is the syntax. The watch method takes 3 arguments. The first one is the source, which is an array. And the first item is a primitive value wrapped by the ref method, which is reactive. And the second one is a function that returns a property of wizard1. And the third one is a ref object. The second argument is the callback function. If anything in the array changes, then this callback function gets called. And here we turned on the deep watch. Okay. If I click increment number by 1 from the scenario 1 demo, as you can see, 2 watchers are triggered. By the way, in this demo, I combined all previous 3 scenarios. Okay, so that's why if I click this button, 2 watchers are triggered. One from the scenario 1 demo, and the second one is from this demo. Okay, next, we also watch wizard 1 value name. So let's change its name. Again, 2 watchers get called. One in scenario 2, one in scenario 4. And also we're watching wizard 2. Let's say we change the wand core of wizard 2. As you can see, 2 watchers are triggered. One in scenario 3 and one in scenario 4. I know this is not easy, but watchers turn to be very useful. Feel free to re-watch the video to make sure you really understand the 4 scenarios. All right, next, let's apply what we just learned to our Hogwarts shopping cart project. Okay, it's Hogwarts shopping cart time. Let's use watcher in this shopping cart. Here is the requirement. I want to define a watcher to watch changes in shopping cart items array. If a change happens, I want to save this array into the local storage of my browser. So even when the user accidentally closes the browser, when they come back to our web page, the shopping cart is not lost because it's saved in the local storage of my browser. So let's do that. Let me scroll down. Right here. Let's define a watcher. Watch. We're watching the shopping cart items array. Then a callback function. In the callback function, we're going to store the shopping cart items to local storage. Local storage dot set item. And it takes a key value pair. So this will be, for example, Hogwarts shopping cart. And then this is the value. Let's convert it to JSON. Okay. Also, don't forget to make it a deep watch. Good. So let me refresh. Next, let me make some changes to this array. So I can increase the quantity of the first one, and then decrease the second one. Okay. And maybe I delete the wand. Then let's press F12. And let's go to Application and take a look at the local storage. Ah, there it is. As you can see, every time I make a change to the shopping cart, it is saved to the local storage. So even though the user accidentally closes our web page, when they come back, we still can retrieve the saved shopping cart from the local storage. That's an important feature for shopping cart. You do not want to lose the content in the shopping cart, right? That's money. All right, great. Next, let's go to the slides and do a summary. In this video, we talked about view watchers. They allow you to perform actions in response to changes in your component's data. You may have this question: how is a watcher different from a computed property? Let's review the definition of computed properties. Computed properties allow you to define a property that is calculated based on other data properties in your component. When any of the dependencies change, Vue automatically recalculates the computed property and updates the DOM accordingly. It seems like they are similar, right? They both invoke a callback in response to data changes. For computed properties, it is important to remember that they should only perform pure computation and be free of side effects. So what are side effects? In Vue.js, side effects are operations that affect something outside the scope of the function being executed, that is outside the computed property, such as making asynchronous API calls, saving stuff in the local storage of the browser, manipulating the DOM directly, or logging into the console. So in the Hogwarts shopping cart project, we used Watcher to save the shopping cart into the local storage instead of computed properties. We use computed properties to calculate the subtotal, shipping estimate, text estimate, and total price. On the other hand, watchers are particularly useful for cases where you need to perform something like asynchronous or expensive operations in response to data change. So again, for computed property, only use it to derive a value based on other values. That's exactly the name, computed property, right? Its only responsibility should be computing and returning the result, not causing any side effects. If you want to perform some actions, some side effects, when a reactive data changes, use a watcher. Another important use case of watcher is to watch props change in a child component. Oh, don't worry, we haven't talked about view components yet. For example, in a child component, we assign the props to a data. If the parent component changes the value of a prop, we need to make sure the child component picks up the change. Watchers can also be used in this scenario. We'll talk about this in a future video. Next, let's go to Learn View 3 with Bingyang project and push the code to GitHub. Here in the app.view file, I've combined the 4 scenarios into one file. In the next video, let's talk about another watch function called watch effect. See you there.